All right, this is the intro video for AP Calculus BC. We're going to be looking at parts of sections 5.4 and 5.5 today. Okay, so we're going to be looking at the derivative and integral of e to the u, and then also some other exponentials and log functions. So we'll do what I hope to be an interesting exercise in class, but for now, what we're going to do, and the exercise will be to kind of prove this to you. For now, we're going to look at these rules and do a couple of examples. So the derivative with respect to x of e to the x is simply going to be e to the x. Like I said, we'll look at a kind of a proof of that in class, but for now, let's just kind of take that at face value and work with it a little bit. The derivative of e to the u, we're looking at kind of the chain rule form, it would be e to the u times u prime. And of course, this will be the more common situation, so keep that in mind moving forward. But it really is just a chain rule, multiplying by the derivative of the inside. Okay, so our first example, e to the 8x cubed minus 2, would look like this. We're looking for a derivative, so we'd write f prime of x is equal to, well, let's remember that the derivative of e to the u is simply e to the u. So e to the u, and then let's remember that any time we're doing a derivative, we've got to consider the chain rule. So we'll multiply by the derivative of the inside, so that would be 24x squared. And we're done. Okay, we're going to jump ahead a little bit in the video, or in the notes here for our next part of our video. So again, we'll kind of look at a bit of a proof for this, but the integral, or the antiderivative of the natural log function, based on what we just talked about, should make sense. So the antiderivative of e to the x is simply going to be e to the x plus c. And then the antiderivative or integral of e to the u du, well, that's going to be equal to e to the u plus c, as you might guess. But of course, this is that composite form, and so this is going to really depend on if you have the correct du. And this is going to be a, did Timmy mess up the chain rule situation, maybe a u substitution if you want. So we'll want to make sure that that du is correct, and if it is, then the antiderivative is simply e to the u plus c. All right, so let's look at our example here, number 1 down below. Okay, so when you look at number 1, you see that it's an integral of e to the u. It's just a question of, is the u the correct u? And so I would look at my inside here, 3x plus 1, and I'd ask myself, what is the derivative of the inside? And of course, the derivative is 3. And so I'm looking for that factor of 3 as the other part of the integrand, and it's not there. But I can fix that. So I'm going to write 3e to the 3x plus 1 dx, and of course now it does fit the chain rule pattern perfectly, but I can't just multiply by a 3 on the inside unless I also multiply the outside by 1/3 to balance that out. So at this point I can find my antiderivative. The 3 just goes back inside. I'm left with 1/3 e to the 3x plus 1 plus c. And that's that. So, like I said, you want to make sure that your du is correct. In case of number 1, the du is not quite correct, but it was a pretty easy fix. Okay, we're going to jump ahead a little further in the notes to finish our video out. Okay, so these are other exponentials or logs where the base is free to be something other than e. But keep in mind, all of these rules should work if the base is e. These are just a little more of a general presentation. So, and again, I think in class we'll explore some of the proofs of these. They involve like change of base and some exponential rules, things like that. But for now, let's take a look at the rules. ddx of a to the x is equal to ln of a times a to the x. Or if you've got a chain rule, because you've got a composite, then it would be ln of a times a to the u times u prime. ddx of log base a of x would equal this, 1 over x ln of a. Or if you get the chain rule pattern, it's going to look very similar. It would be 1 over u ln of a times u prime. And then finally, the antiderivative of a to the x would equal 1 over ln of a times a to the x. And then don't forget plus C's on things like that. Okay, so like I said, those are the rules, and I just wanted to, kind of get those in your hands. In class, I think we'll probably end up proving all of them. Bottom line is we're going to make sure that we know how to use those. You'll find that, this might show up at most once or twice on an AP test, or even on one of my tests, I suppose, but every little point counts. You want to make sure you've got these rules solid and memorized, and they should be pretty easy to apply. So again, I hope that worked for you. We'll do some proofs and some practicing when I see you next time in class.